No, well, it's great to speak to you. And when I release this video, I'm going to email it to every single member of Parliament here in the UK. What
They won't listen to it, Vincent. Forget it. They're not going to listen to that stuff.
Right. Yeah. Well, maybe so. But I'd just like to thank you for coming on the channel. And can I just say that in my sincere opinion, you will get a Nobel Prize for your work. And I just hope that it's not posthumously.
Yeah, well, they don't give it posthumously anyway.
Oh,
so,
right.
And they don't usually give it for the stuff that I'm doing. They give it for some new experimental technique or some new tool or something like that.
Right.
They don't generally do for humanitarian activities in science. It's usually some new sort of procedure that a lot of scientists will use to improve their knowledge of nature and things like this.
Right. Okay. For the audience, what's the difference between gene theory and the mitochondrial metabolic theory? Oh, and by the way, I'm the guy that bought your book.
Oh yeah, well, thank you very much for that. The book seems to be selling quite briskly now, far more than it did when I first published it. It was unbelievable.
Yeah.
So yeah, so well, that's the key. The most important question right now is cancer a genetic disease, or is it a mitochondrial metabolic disease? And it's actually no different than the controversy over the geocentric versus the heliocentric origin of how planetary celestial bodies move. Don't forget, for centuries, people thought that the Earth was the center of the solar system. The geocentric concept of Ptolemy and Aristotle and these guys. And then the Copernican revolution changed the way people think about that. I attribute this new view of cancer to a very similar kind of thing. Even more important, because if you thought the Earth was the center of the solar system, it wasn't linked to hundreds of thousands of people dying each day as the result of you're not convinced that the Earth is that the sun is the center of the solar system. So, but when you say cancer is a genetic disease, when there's massive scientific evidence to say that it cannot be, based on gene expression profiles, looking at all the different ways, the nuclear transfer experiment, all these different things coming together, evaluated carefully, says cancer cannot be a genetic disease driven by gene mutations, for sure. Do cancer cells have gene mutations? Absolutely. Where do the gene mutations come from? They come from damage to the inefficiency of oxidative phosphorylation. So yes, we look at the facts. Cancer cells have genetic mutations. We also know that there are germline mutations in families. These are called germline inherited as opposed to somatic mutations. They are secondary risk factors. They're not primary risk factors. So, and we know that every major germline risk factor, whether it's a Li-Fraumeni, which is the P53 mutation, or the BRCA1, or any of these kinds of things, they all, in one way or another, make mitochondrial energy efficiency less efficient. It affects mitochondrial function. So we have not yet found any cancer cell that does not have some abnormality in the number, structure, and function of the mitochondria, the energy generating organelle in the cell. We have found no cancer cell that can survive without fermentable fuels. All cancer cells, for the most part, have storage of lipid droplets, which are a biomarker for inefficient oxidative phosphorylation. So when you put that together, it clearly says that all cancers that we have evaluated, all major cancers, have some sort of defect in their ability to generate energy using oxygen. So consequently, they're all very, very similar in a dependency on fermentation. Regardless of whether every tumor cell has different genetic abnormalities, but they're all fermenters. So you have to go with the common problem in the tumor rather than the unique differences that exist in every single cell of the tumor. And every single cell of the tumor is a different genetic entity. No two cancer cells have the same genetic constellations of genetic mutations. Yet, every cell in that tumor is fermenting in one way or the other. So the common problem in all cancer cells is a reliance on a fermentation energy rather than an oxygen-dependent oxidative phosphorylation energy. So clearly indicates that cancer is a mitochondrial metabolic disorder, not a genetic disorder. And moving forward with managing cancer and reducing death rate will come once the field accepts this idea that cancer is a mitochondrial metabolic disorder. So the evidence is there. It's just that people either ignore it or refuse to look at it.
One of the videos that you did with Regan Chatterjee, when you said that, his question to you was, I've heard prominent oncologists here in the UK, Professor, state that there's these genes and those genes and whatever. And that was the light bulb moment for me. And it absolutely blew me away. And it was at that point that I decided, for every last breath I can draw, it has to end. I mean, you've said that it's the greatest tragedy in medicine, but I think it's the greatest tragedy in humanity.
Yeah, well, you can certainly view it that way. Yeah, I mean, when you consider the suffering and pain and what we're doing to human beings in the name of trying to help them, these are well-meaning people. We're not out there during the Spanish Inquisition to torture people to death, but a lot of the therapies that we're using do in fact torture the people to death, and about 50% of people with cancer actually die from the treatments rather than from the disease. Oh, yeah. So it's really a tragedy of monumental proportions, but it doesn't have to be that way. The problem is that it's so hard to redirect the direction of the ship. The momentum for viewing cancer as a genetic disease is so powerful in the scientific community, in the hospital systems, in the pharmaceutical industry. It's a giant momentum that's very profitable for large portions of the economy. And I think it'll change once we can figure out in part how to shift revenue generation from one type of approach to management to another type of approach to management. So that's going to have to be. You just can't shut down major parts of the economy because the theory under which you're working is incorrect. That should be the motivational drive to change. But you have to have something to offer in a replacement. So my view is some sort of a hybrid system at first, where we can continue to use immunotherapies and certain other kinds of toxic drugs, but manage them in a little bit, change them in a little bit of a different way that they can work together with a metabolic approach. So you'd have this metabolic hybrid kind of a system that will eventually give way to more of a metabolic approach as new concepts come online. Actually, as more knowledge comes online, basically. So we have to look at it that way, I think.
Yeah, well, I actually think that it will be a disruption. It'll be a disruption from the bottom up, because, like you've said in many of your podcasts, that people want to live, and so people will seek out the information, and if they can't get a doctor to do it, then they'll self-medicate and spread the word. And I think it'll be a disruption from below, just like the iPhone disrupted Nokia, just like electric cars are going to disrupt the internal combustion engine, just like electric becoming renewable. I think that's maybe. Where did the mitochondrial metabolic theory originate?
Well, it certainly originated with the work of Otto Warburg in Germany during his long years of working on cancer metabolism. And I'm writing a renewal paper. I'm working on it now, where Warburg made his mistakes, but his general concept was correct. It's just that he tried to be too rigorous in the way he was quantifying energy production in a cell. So you have to realize that at that time, and even today, many people think there are two forms of energy, One is cytoplasmic fermentation, glucose-driven cytoplasmic energy through, they call it aerobic glycolysis, or it's called aerobic glucose fermentation, and oxidative phosphorylation, energy through breathing oxygen, producing the majority of energy. And Warburg had claimed many years ago, based on his biochemical readouts, that there was something wrong with the oxidative phosphorylation in tumor cells. There was something wrong with the ability of a tumor cell to generate energy through oxygen. And therefore, and don't forget, the rise of understanding energy came from mostly a German school with fermentation, the Emden, Meyerhoff, Parnes pathways, and Warburg himself characterizing fermentation energy. And but we have now identified another major source of energy not known to Warburg or others, and that's a fermentation process that actually occurs inside the mitochondria, using amino acid as the fermentable fuel, which is new. Warburg didn't know anything about that. So we have to find out what happened to Warburg's central theory, and there's several reasons for that. He was the dominant person in energy and cancer metabolism most of the 20th century. And then all of a sudden, it all fell apart, probably around the mid-50s, 1950s, when the Watson and Crick discovery of the structure of DNA and finding genetic mutations inside cancer cells led to a whole shift in the view of what cancer was. Jacob and Monod, they showed that genes can control biochemistry now. So they threw Warburg under the bus, basically, just moved on from him, and only to realize that he had a lot of key information that's now becoming recognized, but they still refuse to believe that mitochondria are the problem, remaining the focus on the mutations and the nuclear problems. And this comes from many top papers saying that Warburg was right on the dependency on fermentation, but he was wrong on the mitochondrial problem. He was not wrong. He was absolutely correct on the mitochondrial problem.
Yeah. And what a character. Nobody's mentioned this, but he was a gay man living a gay life, so I've heard, in Nazi Germany, and was an open Jew. But Hitler was so afraid because his mum died of cancer that.
Well, that we have to be careful about that. That was brought up in Sam Appel's book, Ravenous, and but I have his book too. I have this book. This is the book Otto Warburg here. This is a very hard book to get a hold of.
Right.
Okay. This was written by Hans Krebs.
Right.
Which was a Nobel received, also a German who went to Oxford, England.
All right.
And did his work,
My daughter
work
went
at
to
Oxford.
Huh? My daughter went to Oxford.
Oh yeah. I did my sabbatical there too at Oxford.
It's gorgeous.
And my son has a DPhil from Oxford. But anyway, Krebs wrote this book on a biography, cell physiologist, biochemist, and eccentric, which was pretty good. But it doesn't ever, in this book, describe Warburg as being gay.
Right.
And it's also interesting that Warburg was planning to get married to a woman that he loved, but it turned out that his father said, any great scientist should never get married because you're going to dilute too much of your time away from what you're. So if you want to call that gay or not, I don't know what you want to call it. And the other issue, of course, is the Jewish issue, which, don't forget, his mother was a Protestant. Warburg was not a full Jew. His mother was a Protestant. He came from the Warburg family from the 1500s, which was a Jewish family. Now, you are correct. I don't think Hitler cared too much about half Jews, full Jews, or whatever you wanted to classify them. He would exterminate them regardless. But he he knew the value of Warburg as being the only person on the planet that had a remote chance of curing cancer. And you're right, Hitler's mother did die of cancer, and Germans did. It wasn't just Germans that were upset about cancer. I think most people who knew about it probably feared it because it didn't represent a pleasurable way to die. It wasn't quick. It was horrible and painful. And Warburg, Hitler felt that Warburg might be the one that could possibly bring this disease to an end in some way or form. And he denied Warburg. Warburg never received the Nobel Prize for his work on cancer. He was nominated twice, but never. He received the Nobel Prize for his discovery of the cytochrome C oxidase, which is the respiratory enzyme. So he knew a hell of a lot about the energy metabolism of a cell, but he never received the Nobel Prize for his work in cancer, mainly because Hitler denied it. And then, of course, after the war, the field moved on to other what they considered more important areas.
Yeah. So where did the gene theory come from?
The gene theory's been kicked around for a long time. That actually started with Theodore Boveri. Sorry.
Yes.
The Theodore Boveri was a prominent German scientist in his own right. He was the one who he and a graduate student, Walter Sutton, graduate student at Columbia, and Theodore Boveri were the first to link Gregor Mendel's abstract genetic factors onto chromosomes, linking abstract to hard biological evidence. But then they went out and looked at the chromosomes in cancer cells, and Boveri said maybe there's some connection between abnormal chromosomes and cancer. But he said, I'm very embarrassed because I know nothing about cancer, purely speculative, and it could be something in the cytoplasm just as well as something in the nucleus. But they latched onto that, made him the founder, the founding father of cancer as a genetic disease, and they're still describing Boveri as the guy who linked this up. This was in 1911, I think. Goes that far. So you have, and then of course, when nuclei were looked at in cancer cells, you found a lot of chromosomal abnormalities, and you found a lot of genetic mutations and all these kinds of things. But people thought, whoa, that's the origin of the disease. But it turns out that the mitochondrial energy metabolism controls the fidelity of the nuclear chromosomal elements, controls the cell cycle. And then, of course, if the mitochondria are defective, they throw out reactive oxygen species, which are carcinogenic and mutagenic. So the mitochondria defect is ultimately responsible for the dysregulation of growth and the mutations, and all of the characteristics that we see in cancer are all linked in one way or another back to the inability of that organelle to produce energy efficiently. So once you realize that, then the management of the disease becomes much more straightforward and clear. If the
downstream effects.
Yeah, if you know the cell can't live without fermentation, then you say, and first of all, no cell can live without energy. So if you can't get energy from oxidative phosphorylation, you have to rely on fermentation. And this is what Warburg said. And many folks in the field also recognize this. So the idea then is, what are they fermenting? And we have done a deep interrogation, and others have done the same thing, and they can't live without glucose and glutamine. We cannot find any tumor cell that can survive without glucose and glutamine. So that becomes a clear strategy for how to manage cancer. They can't respire. They can't use ketone bodies or fatty acids for energy. They're completely dependent, almost completely dependent on glucose and glutamine. So the strategy for managing cancer is not complicated. Transition the whole body over to nutritional ketosis, and then simultaneously restrict the availability of glucose and glutamine using diets and drugs. So this is the framework that will eventually become the standard of care. And it just has to be recognized and not ignored. That's the key.
Yeah, that was actually going to be my next question. What is press pulse therapy? But you've just answered it right there. Now, when if I go on Twitter and I see a post from the largest cancer charity here in the UK, which is Cancer Research UK, and of course they're chasing genes. And when I see the I have to reply and say, you know, what are you doing? And then I post some of your science, either one of the papers or one of the what you've just said, you know, as a short video, and all I hear is crickets.
Well, that's because they can't deal with it. They can't find a way to prove me wrong. And when you're locked into confirmation bias, which is the field, which is driving the field, you can't, if you're part of the system, to stand up and say, we're not on the right path here, you get smashed down, and you're ostracized. So, you know, I would like to have someone, the arguments that we get oftentimes is, well, those studies haven't been repeated. And the answer is they've been repeated dozens and dozens and dozens of times. You just happen to not choose to look at the repetition, how they've been repeated, right? So, there's, you know, if they were so important, we'd do clinical trials on this. Well, how can you do clinical trials when the field doesn't understand what you're doing or why you're doing it? So, you know, there's always some non-scientific explanation for why we're wrong. And if you look at the guys that think cancer is a genetic disease, it's unbelievable, because I share it with my students. They still continue to try to figure out why the genes aren't responsible for the dysregulated growth. There must be something they can't see or find. They call it a knowledge gap, or they call it the dark matter. There's some crazy terms that the gene guys continue to use, rather than realizing it's not a genetic disease. It was no different than before the Copernican revolution, when they kept putting more and more epicycles into trying to figure out how the planets were moving. And as a matter of fact, when Copernicus did his seminal work, he was using the same technical strategies that others were using to figure out why all these movements of the planets never really fit all the mathematical formulations, until he replaced the Earth with the sun, and then all these things made sense.
Yeah.
You know, everything fell into place. And I think that's the same thing we're confronted with today with the genetic theory. Once they realize it's a mitochondrial metabolic disease, then everything will fit into place. All their mutations, all the dark matter, all the crazy stuff they're talking about, and it explains the driver genes. Now, when they realized that not all somatic mutations were responsible for the dysregulated cell growth, if any at all, they then came up with some genes that were called driver genes. These are the ones that drive the dysregulated growth.
Yep.
Now we find all of our normal cells are loaded with driver genes that never form dysregulated growth. So now we call that the dark matter, and we call that the gap in knowledge. Rather than saying it's not a genetic disease, we're still hunting for absurdities when the evidence tells us we're on the wrong path. And this is why you hear crickets.
Yeah, absolutely. And according to Cancer Research UK, 10 million people will die this year, which, you know, you always talk about 1,600 people a day dying from cancer, 1,700 people a day dying from cancer, but that's just in the States. And if 10 million people worldwide die of cancer, that's 27,000 a day.
Yeah, well, that's true. And in China, when I went there, they were losing 8,100 people a day. Obviously, the population is much, much larger, so you have a lot more cancer deaths, and it's getting worse all the time, and more young people are getting cancer. So and the pharmaceutical companies are bracing for all new drugs. They predict they're not seeing drops; they're only recognizing, you know, that there's going to be more profitability in this disease because it's getting worse and worse. And our goal is to drop the death rate by 50% in 10 years. If you change what the disease is, you're going to see a dramatic drop. We don't ever say we can cure, metabolic therapy can cure cancer. What we say is metabolic therapy offers another way to manage the disease, leading to an improvement in quality of life and overall survival. Whether people are actually cured or not, we can't be any more certain than giving somebody immunotherapy or radiation or chemo. the issue is we think we can manage the disease far more effectively with less toxicity, giving people a much greater opportunity to live on the planet. So that's what our prediction is. Whether it leads to a cure or not, I don't know. Maybe it will, but we're not saying it will.
No, just managed like Dennis Stacey is. Yeah.
When you hit me with some of these names, having thousands of these names come through my computer
inbox,
all
absolutely.
the times, all of a sudden you become name numb.
Yeah, yeah, like Theodore Bovary.
Yeah, Theodore Bovary. You know, you're talking about these guys all the time, and then you come into a different situation and you're trying to figure out, you know, who this is, and then his name. You know who he was. You know what he did. You just can't remember his name.
Yeah.
And it's name skipping and things like this. As you get older, you start to fall into this kind of a category.
Oh, listen, my friends take the mickey out of me for being old, and I'm 61. And you know, when I went to school, there was no history. That sort of rubbish, yeah. Anyway, yeah. Don, let me get on to Don. Metabolic therapy being a diet drug combination. Unfortunately, we can't go to hospital and get Press Pulse Metabolic Therapy. But people who are forced to, they are forced to self-medicate, and I wouldn't recommend that to anyone. But that's what people do. They want to live. Now, it is for sale here online, but I've heard that as an individual, you get refused. So what sort of bullshit would one have to come out with in order to obtain it?
Well, that's probably the most important issue that we're dealing with right now. We have identified this drug as a very powerful drug for managing the glutamine part of the dependency of the cancer cell. And it was surprising to me because I looked at the original paper by McGee et al., where they looked at Don in a bunch of cancer patients, both children and adults. And what they found was, and some people responded really well, others didn't. And some children did pretty well with leukemia. But they said, well, it had some toxicity for sure, but it wasn't like doxorubicin, which you call the red devil, and stuff that we're using in patients today. And the other thing too is they didn't use it in the full context of targeting glucose at the same time. So you're not going to get the full power and benefit of the drug if you're not using it in the right context. And I think the thing of it is, once you understand that the tumor cell cannot survive without glucose and glutamine, then the first thing you want to do is, what are the best drugs for targeting glucose and glutamine? And we know diet can bring that blood sugar down really well. So that's a good way to do that. And you could push it a little bit with some 2-deoxyglucose or one of these other kinds of drugs, but you'd use them at very, very low dosages when you're in therapeutic ketosis. The glutamine issue now becomes the outstanding problem. How do you target glutamine? Yep. And glutamine is an essential amino acid. It plays a role in so many important parts of our physiology. That's where the pulsing comes in. And we looked at the literature and we said, well, this drug Don, which is it looks almost like the glutamine itself. The structure of Don and glutamine are almost very, very, very similar. And it was isolated from some bacteria. It was an antibiotic of some sort. And it worked really well for some cancer patients, but not on all cancer patients. But then when we use it in pulsing as short bursts of Don together with metabolic nutritional ketosis, we found a powerful synergy between this drug and reduced glucose. So we know, I talked to a pharmaceutical rep one time, and he said to me, if you have a drug that works really, really well, but for whatever reason it can't be used, like maybe too toxic, and you find a way to remove the toxicity and keep the therapeutic potential, that's like discovering a new drug. Well, I published a paper with my colleague, Dr. Mukherjee, saying specifically this when we were able to show how powerful it was on brain cancer, and the field ignores it, that you can't make any money on the damn drug. So we have to recognize that in order to improve cancer, we have to figure a way not only to help the patient, but we have to make a big profit on it at the same time. So right now, I don't see any drug that's come along from the pharmaceutical companies that is as effective or powerful as Don, but they won't use Don because it's not profitable.
Yeah,
So
'cause it's off patent.
yeah, it's off patent, and of course people think cancer is a genetic disease, so they focus on immunotherapies, not on the real thing that's the problem. So the hot thing today is immunotherapies, right? Keytruda, Opdivo, CAR T immunotherapy.
A friend of mine's on that, yeah.
Yeah, they're all based on the somatic mutation theory of cancer. Well, if the somatic mutation theory of cancer is not correct, none of these approaches will ever be optimal. Not to say that they can't help a person here or there or even cure somebody here or there, but it doesn't work for the majority of people. It only helps a few people, and about 20% of people, which is a good number, can be helped.
Yeah, yeah.
60% nothing, but then you got 20% of the people those drugs will actually accelerate, cause hyperprogressive disease, killing the patient before the cancer does. But metabolic therapy doesn't do that. Metabolic therapy will not kill anybody. If anything, it makes them healthier. At the same time, you're degrading your tumor. But it's a great way to make other drugs work even better. So I think that's going to be the future. Bringing in some of these other drugs, lower dosages, work with metabolic therapy could potentially drop death rate at first, and then get progressively better as we understand more and more how to target the two fermentable fuels driving the dysregulated cell growth.
I read your paper with mebendazole and Don as a control, but Joe Tippins in a video that I watched of him not so long ago, he said that he cured his cancer with fenbendazole, the dog dewormer. Here in the UK, it's as cheap as chips. You can buy it on Amazon or wherever for treating your dog's worms. Did fenbendazole make it into your study?
No, we haven't done fenbendazole yet, but others have used it. It's, as I said, it's another drug, very parasite drug. And they're both fenbendazole, mbendazole. There's a couple of other very bendazoles. They're all like very similar to each other. One of my colleagues thinks fenbendazole works better for non-brain cancers, where mbendazole might work a little bit better for brain cancers. We show that when you administer mbendazole with under nutritional ketosis, the ketone, the high levels of ketones facilitates delivery of the drug right through the blood-brain barrier. So you can actually get more drug on target for brain tumors when you have the patient in nutritional ketosis, which is another blockbuster thing that nobody seems to be picking up on. I can't understand it. I mean, they're spending hundreds of millions of dollars on drugs to permeate the blood-brain barrier, when all you have to do is put the patient in nutritional ketosis and then deliver low doses of your drug. So again, we proved that. We actually did mass spec analysis of the drug on target. We saw that for two totally different structural small molecule drugs. So it's a general way of getting drugs through the blood-brain barrier on target.
Yeah, by being in therapeutic ketosis, and I thought it was there's great what he said about one thing that Elon talks about is fate loves irony, and in 1984, the year 1984, the fox was invited into the hen house. Yeah,
that was Orwell's year.
Yeah, exactly, exactly. Fate loves irony.
Yeah, I know. And but if you look at the history of the National Cancer Institute, their progress towards the cure was not as fast as what they had hoped. So they invited the drug companies into the academic labs to help facilitate this. And how's that working out for us today?
Oh, absolutely. Yeah, for sure. Not good. Well, the thing is that that here in the UK, we've got the National Health Service, so it's free to any British citizen. You go to hospital, you have any cancer treatment, anything. It's free at point of delivery, and it all comes out of the taxes. So that was my thoughts on when I said that I would email this interview to every single member of Parliament in the UK, because it must be costing us an absolute fortune. Feeding these drug companies.
Yeah, well, it's true, and they work through the governments as well. So there's deals being made between the companies and the government. We do the same thing in this country, even more so. Don't forget, the business of America is business.
Business, yeah. Yeah.
And the insurance companies benefit too from having high, very costly insurance policies. So they don't want, and nobody wants anything cheap. It's got to be as expensive as you possibly can get it, because everybody will benefit from that. Everybody except, of course, the patient, who suffers and dies as the result of all these kinds of things. But yeah, so we were kind of surprised by this. We thought the insurance companies would be really on board with this, but no, they're just the opposite. They're the more costly the treatments, the higher the insurance policy it becomes, and you make more money that way. So again, not to say I'm not opposed to anybody making money on any of this stuff, but it's got to be reevaluated in light of the suffering and the death of these poor patients. We know that we can improve the system dramatically, but I'm not the entrepreneur. I think we have to leave that up to others.
Yeah, well, I from a personal perspective, I just think the people are going to treat themselves and get better, and it'll snowball until everybody says no to the hospitals. Oh, that's English, by the way. Stuff you. I'll do metabolic therapy.
But you got to be very careful too, because there's a lot of charlatans out there that will be telling these poor folks that we have a better drug than Don. This drug is going to be this and that. You're going to, and the poor person doesn't know. So you really have to have professionals that really understand what's going on and how to approach this, because self-medication is good up until a point, but you really need to know what the parameters are, how you're collecting data. You need to share the data with a knowledgeable professional to know whether or not you're on the right path. And you really need to know what are the appropriate drugs with dosage, timing, and scheduling to improve my outcome. But the nice thing about metabolic therapy is that the patient themselves will play a much greater role in their management through the consultation and working with knowledgeable physicians and oncologists that understand the concepts of what you're doing. That's also an educational mission that has to be brought into this whole picture. Because certainly I'm not a fan of having everybody go out and self-medicate. Because even if I were to have cancer, and I'm writing all the stuff on this, I would still work with some of my colleagues that are actually treating patients in the clinic, and we would work together as a team.
Yeah.
Because with metabolic therapy, every person must be viewed as their own control. You can't group people into the same treatment strategy based on age, gender, body weight, overall health parameters. Every person is their own control. They have to be evaluated by themselves in relationship to what their health status is at the time of diagnosis, and how we move this individual through the gauntlet of procedures and processes to achieve a greater level of health at the end of the game, at the end of the time here. So, we want to manage cancer. We want to make sure that it's managed. If we can see it shrinking and it becoming indolent, like Pablo Kelly from Devon, England.
Yeah.
He's still alive now.
I'm friends with him on not friends, but
he's still alive.
We follow each other on X.
Yeah, he should have been dead years and years ago. But he chose a different. Is he cured? No, he's not cured. But he's learned to live with every 2 or 3 years getting a tumor debulked. It's manageable. He's managing a terminal disease to the best of his ability. How many other folks out there could be doing the same thing, rather than perishing as the result of toxic poisons and things like this? And we're also recognizing that not everybody will be saved, that metabolic therapy will not likely save everyone that has cancer. So, but it can certainly
give you a better chance if you do metabolic therapy in the first instance rather than go through the standards of care.
Absolutely, but and the idea of what is metabolic therapy. When people say, "Oh, I know chemotherapy," what's that? Well, we're going to use these drugs that are going to try to kill tumor cells. Radiation therapy, we understand what that is. Immunotherapy, these are using your immune system or drugs to help your immune system kill tumor cells. Well, we say, what the hell is metabolic therapy? And metabolic therapy is simply a way to target the metabolic requirements of your tumor cell. So your tumor's living on fermentation fuels, glucose and glutamine. Well, how do we target glucose and glutamine while maintaining the health and vitality of the whole body? That's metabolic therapy. Nutritional ketosis, getting the body into a nutritional ketotic state. How do you know that? Well, we developed the glucose ketone index calculator to allow patients to know when they're in nutritional ketosis with a meter. Like you can use free Libra meters, you can use glucose ketone monitoring meters. That industry is coming along big time. So that's going to help cancer patients know when they need to take drugs and concentrations and timing and this kind of thing. So it's a work in progress.
Yeah, absolutely. And how's the paper doing?
They mean the Press Pulse paper, or
no, sorry, you've got the Press Pulse paper out, which I've read. No, you were talking about dosage timing and scheduling for
that paper.
for glioblastoma patients.
Yeah, that's under review right now, and we have over 30 physicians and scientists as co-authors on this paper. So we're hoping that once that paper is published, then you'll have a how-to, a practical manual explaining in very great detail all of the issues that one would encounter in treating patients with metabolic therapy. Now, it was made for glioblastoma only because they really have nothing available. No advance in that disease in 100 years. So we've seen that.
A guy that I went to college with, Bob Bullard, had glioblastoma and went through standard of care. And I don't need to tell you anymore, do I really? He's no longer with us.
No, and it's a real tragedy because we know we can save a lot of these people, have them live a lot longer than would have ever been predicted. But when you haven't had any advance in treatment, overall survival in 100 years, then you might want to target that. If you can double, triple, or quadruple the overall survival of patients with glioblastoma, you can manage any cancer. And as I said, you can do lung and colon and breast and bladder, melanomas, everything. So and that protocol that we have for glioblastoma can be tweaked in a very easy way to manage most other cancers.
Yeah. It just amazes me, the field. It was Einstein that said, it's insanity to keep doing the same thing over and over again and expect different results.
Yeah, well, I thought about that, and I always thought these guys that do that, the clinicians, I don't think they're expecting any difference in results. They know the patient is a dead man walking, but they don't have any other way to treat the patient. They don't think of, they've been trained to irradiate and poison people. They're not trained to think of cancer as a metabolic disease. And I don't want to say they're poisoning the people. They're using poisons to treat the people. Are they saying, no, I'm going to poison you to help you get healthy? They don't say that, but the treatment they are doing is, irradiating somebody with a brain tumor is like, you might as well sign their death certificate as you're getting your radiation.
Absolutely. And it really, really bothers me, actually, because I just think, what must it be like to be one of these oncologists and get a patient come in and you look at them and you know that what you're going to do to them is
well, they don't know. That's the thing. They don't know. And when I brought it to their attention, they get very upset and angry. They think they were trained to do this with the idea that you're keeping that patient alive a little bit longer than if you didn't irradiate them. So they're thinking that by irradiating them, I'm allowing that person to survive on the planet for a few extra months if I didn't irradiate them. But the idea is, but if I don't do any of that and I do metabolic therapy and I show that your radiation is actually contributing to the recurrence and demise of the patient, that's a very unsettling thing. And they never knew that.
Yeah.
But the problem is these guys are not trained to understand the biology or biochemistry of the disease they're treating. So it's like a profound lack of knowledge. They're knowledgeable on knowing how much radiation your brain can receive before smoke starts coming out of your ear. But they're not known to what's the biochemical consequences of what I'm doing to the microenvironment of that tumor. So, and again, treating patients with temozolomide, they just dump massive doses of steroids on top of you. knowing this is all putting accelerants on a fire. So and not they don't know that they're not trained to know that. So who do we blame for their lack of knowledge? Do we blame them, or do we blame the system that trained them to do what they're doing? It's a really difficult situation we're up against, and the poor cancer patient has no clue about what's going on in any of this front.
No, it's yeah. I mean, I would be taking the paper into the oncologist with me.
Well,
read this before you start. Read this before you start treating me.
They get angry. It's not like in fact, they just release you as a patient. Say, we don't want to treat you anymore. And the oncologist. So where you find the resistance is when the patient brings the paper to the oncologists, and the oncologist said, if this were important, I would have heard about it. And the answer is no, you wouldn't have heard about it, and you're not open-minded enough, and you're part of the the confirmation bias of the field that this is a genetic disease and we must treat it this way. So you have a lot of firewalls and impediments standing in the way of moving metabolic therapy into the clinic. So again, it's a knowledge base. And always remember what the Catholic Church did to Bruno and Galileo when they tried to challenge the geocentric theory. They were not dealt with kindly.
No.
So but we are up against the same situation, a very similar kind of situation, and it takes time to re-educate the field into knowing what the right path is.
Yeah. I have some questions from some of my audience. Kent Jacobson from Denmark. He did water-only fasting for 60 days and halved his PSA numbers from 370 to 185 and reduced his weight from 89 kilograms to 67 kilograms. And he said he'd like to fast again, but in his words, he's scared of weight loss.
Yeah, well, I think that's where you have to bring in the drugs, the Don and the Embendazole and these kinds of things, because he's really, if he measures his glucose ketone index, he's probably below 1 if he were fasting that long. So in the strategy that works is when you get the patient into a low GKI through water fasting or zero carbohydrate dieting, that's when you bring the drugs in. And the drugs will then more selectively target and kill the tumor cells. Fasting has cured some cancer patients, but it's a real bitch. I mean, for the reason what you just said, but it's part of the overall process. But it's generally not going to be curative in and of itself for most people. Not to say that I've seen some people that have completely eliminated their tumors with that, but that's why we have Press Pulse Metabolic Therapy, which brings drugs in when patients are in this situation. They don't have to fast for 60 days. They can fast for 2 weeks, which is still enough. And then once you're into those low GKI zones, then you come in with the drugs. But the drugs aren't available, and people don't know how to use them. No. So that's another problem.
The same guy asked for how long do you plan keeping up your fantastic work? I think I know the answer to that, but
probably until I'm demented or dead or something.
Yeah.
You can wheel me out of here.
Yeah, you and me both. While ever I'm breathing. Yeah, what happened to him? He died. How did he die? He stopped breathing. Yeah. Another question from.
Unless you're a zombie, the zombies they seem to be alive without breathing. They use fermentation energy, by the way.
Yeah, they must do. Yeah. Another question from the same guy. Some men with prostate cancer choose to be treated with the female hormone estrogen. It both lowers the testosterone level and the PSA number. Do cancer cells live off testosterone? And no, glucose and glutamine.
Oh, no, yeah. I mean, the cancer cell can't eat testosterone. Now, testosterone can be a facilitator to get fermentation fuels into the cancer. But if you don't have fermentation fuels in the environment, then they might have to eat the testosterone to stay alive, but they're not going to get much energy from that.
Yeah. Your $100 bill would be disappearing if they did. Yeah. Next one. What is your cancer kit, and can he get one? If you let me have one, can I publish it on the website?
Well, it's going to be similar to what we have, more detailed in what's right now. It's only a stopgap for the big publication that we're
Right.
working on.
Yep.
And it just gives patients an opportunity to read literature to support their choice to do metabolic therapy, and it also gives them a guidelines as to what they can do right now before they have the full package available for them. So the kit is just that I send to folks. I asked them, if it works, please consider making a donation to Travis Christofferson's foundation or to us through Boston College. No requirements here. I always say, don't donate anything unless it works. Why the hell are you going to give me money if the damn stuff doesn't work, right? This is very different from most other people.
Yeah, like Keytruda.
Yeah. We want to make sure that you get benefit from this. And if it helps you out and you feel better and you live longer, then you might want to consider making a donation to one of these places.
From Alison George from British Columbia. Glucose management, most people can get to 75 ml per DL, whatever, aka 42 millimolar, with ketosis and either berberine or metformin. But getting lower than that is extremely difficult, and for various reasons, people just can't get lower. So, what medications can be added?
For getting glucose lower?
Yeah.
Getting glucose lower? Yeah, well, that's why we developed the glucose ketone index calculator, because people can get into a low GKI value. You don't have to get your glucose so low, as long as the ketones can be elevated, because the body then goes into a new metabolic state.
She said that.
65 to 55 to 65, but you'd be surprised how hard it is. People who don't have cancer can get into those zones much more easily than a person with cancer. It turns out that having cancer, the stress elevates glucocorticoids to some extent, preventing glucose from going down that low. So stress management is part of the Press Pulse procedure as well.
Yep.
You have to have stress management. But, the lowest glucose that we have ever seen in a human being was done by a scientist named Dr. Drenick, where he took obese people, fasted them for 21 days, water only, and then injected insulin into them, which was unbelievable, and brought their blood sugar down to 9 milligrams per deciliter, 0.5 millimolar, which every physician on the planet would say that person should be dead. And the fact that they weren't, and they were cognitively intact, showed how powerful ketones are to replace glucose as an alternative fuel. So clearly the human body can push blood sugars down really, really low as long as the circulating ketone bodies are up. So once you're in that zone, then the cancer cells can't adjust. They can't adjust because they have too many mutations, and the mutations prevent them from being flexible. So cancer cells are dependent on fermentation, inflexible in using anything other than fermentation. So again, we're using the normal cells of the body to put pressure on the tumor cells and eliminate them.
Yeah. From K.A. Karim from Ireland, you've heard of success. Have you heard of success using metabolic therapy with Hodgkin's lymphoma?
Yeah, well, again, in my paper, I looked at Hodgkin's lymphoma. I look at every major cancer. And the first thing we look at is two things. Number one, what do the mitochondria look like in patients with in tissue, cancer tissue from patients with Hodgkin's lymphoma? And when you look at the electron microscopy of mitochondria, you find abnormalities in number structure. And when you do functional studies, you find functional abnormalities. Number one. Number two, when cells can't use oxygen for energy, they store fatty acids as lipid droplets in the cytoplasm. Hodgkin's lymphoma has lipid droplets in the cytoplasm. They have bad mitochondria and they're storing lipid droplets. Clear sign that they are dependent on fermentation for survival. So the answer is yes, Hodgkin's lymphoma would be manageable with metabolic therapy.
And he also asked, how can someone take DON intravenously if it comes in a powder?
Oh, well, you have to dissolve it in saline. You have to prepare the solution, the saline solution. This is what's done, and then you deliver it in a saline phosphate buffered saline solution. That was another problem. They administered DON to the. It was another thing. That's another thing why it didn't have the blockbuster effect. They were administering it with sugar. with a lactose drip. So there was a Don with sugar going into the
on a cookie.
Yeah. That's another reason why it didn't have as powerful effect. We don't deliver it with a lactose drip or one of these kinds of things. So again, it takes more power when there's no sugar involved.
Yeah. From me, we've all heard about hyperbaric oxygen, and I've seen a number of videos where you've discussed hyperbaric oxygen. But have you heard of EWOT? Exercise with oxygen.
Oh, yeah, well, I think exercise is an absolute essential ingredient for metabolic therapy. Exercise can, in fact, lower glutamine to a certain level. George Cahill from the Joslin Diabetes Center showed some evidence to support that. But exercise with metabolic therapy is exercise is a part of metabolic therapy. It works together with the diets and the drugs all together synergistically to degrade the tumor cells.
So exercise with oxygen, I'll just let you know, is basically you get something like an oxygen machine that my mum had one when she had, she's died now, but she had emphysema. And so she had a machine that would take oxygen out of the air, and I think it was like 95% pure as it came out of the two pipes. You see the people with the pipes on their nose. Well, the idea is that you use one of those machines to fill up a great big bag. And then go on a treadmill breathing pure oxygen, or on a bicycle or something like that.
Yeah, well, it might be okay. We haven't tested anything like that. That's different from hyperbaric oxygen.
Yeah, no,
where
absolutely.
The oxygen then becomes dissolved actually in the blood. When you're breathing oxygen, your hemoglobin will take only as much as the hemoglobin can carry in the hemoglobin molecule of the red blood cells. But when you put it under pressure, the oxygen actually now becomes dissolved in the blood. It's part of the liquid itself. And that puts more pressure on the tumor cell, especially if you are in nutritional ketosis. Again, the baseline is nutritional ketosis, and then you add on oxygen therapy, exercise therapy, and all these other kinds of diet drug combinations. That's the most effective way to slowly degrade these tumor cells.
Yeah. Brilliant. Okay, that's great. That's all my questions. If you have anything else to add.
No, I think this is good, Vincent. I think that the more information that gets out, the more people start to realize that there is a very different strategy for managing cancer. But the challenges, as I've mentioned, are there big time. And but it will come from the people predominantly. And once more and more folks hear about this, they want to do it. The system will have to slowly accommodate these folks. So, and then you're going to see the big changes, drops in cancer. And not only that, you're going to get healthier in many different ways with respect to diabetes, obesity, hypertension, high blood pressure. A lot of these other issues will start to slowly resolve as well. So it's going to be an interesting future as long, and it's a challenge, but listen, challenges, you need to have challenges.
Oh, absolutely, yeah.
And success comes when people finally realize that you were correct. But sometimes they don't want to hear about that. And that's the challenge right now. So your podcast and your information coming out will help and educate more and more folks.